Part 6 of 6. It looks so good to see that. We've been waiting for this all day long. Okay, so what are we going to be looking at right now? Key word right now is area with a circle. A couple things to keep in mind. The area of a circle is pi times the radius squared. The circumference is either pi times the diameter, but we usually, more often, will see 2 pi times the radius. 2 times pi times the radius. Now there's something else that you guys will see in here, and that's the word called an apothem. We'll get right into that. So the idea here is you can take shapes that are regular, where every piece around the outside is equal, and if you were to split it up into triangles, so I'm splitting this up this time into 6 equal triangles because there's 6 sides, but you could do it for regular polygons, as many sides as necessary. And we need the apothem, which gives us the height here for this triangle. And if we knew the base as well, then we know the area of a triangle is half base times height. Now, okay, there's this crazy thing going on right here. The area equals half times the apothem times the perimeter. It's the same thing as doing one triangle and multiplying it by the number of triangles. Well, let's try it. Let's see what's going on. What is true about the sides of a regular polygon? Okay, so a little bit of just vocabulary there. When you hear the word regular, that means all sides are congruent and all interior and exterior angles are also congruent. How many central angles are in a regular octagon? Okay, so for an octagon, there's 8 sides. That also gives us 8 central angles. What is the perimeter of a regular nonagon? Nonagon means 9 sides, and it's got 8 feet for just one side. Well, that's 8 times 9 sides total would give us 72. Alright, so use the formula of the area of regular polygon. Okay, so they're telling us to use the formula. I'm going to show you just to use some common sense here. It's really not as hard as you would think. Okay, so here's one triangle. And altogether I would have 8 of them because there's 1, 2, 3, 4, 5, 6, 7, 8 sides. And for one triangle, the area of just one triangle, that's going to be half the base, which is 12, because all these bases are 12, all the way around. So half the base times the height, which in this case is 6 times the square root of 3. Excellent. Okay, so we got that information there. How does that help us? Well, we would calculate the area of one triangle, which is half of 12, so that's 6 times 6 square root 3, which is 36 square root 3. That's just the area of one triangle. The area of 12 triangles, not 12, 8 triangles, because there's 8 of them, if you were paying attention, is going to be 8 times that. 8 times 36 square root 3. Simplify if we needed to. 8 times 36. 288. So it's going to be 288 square root 3. Alright, now for this one, seriously, some people don't even think about it. It's a square, 14 by 14, which is going to give us 196. But I'm going to show you how we could come up with that same answer by doing it after splitting it up into 4 triangles. Okay, so for this triangle, the area of the triangle is half base times height. The base in this case is 14, and the height is 7, which is going to give us how many? What do we got here? 14 divided into 2 is 7, times 7 is 49. So that's the area of one triangle. The area of 4 triangles is going to be 4 times 49, which guess what that equals? It's 196. Okay, so whether you do it using an apothem and multiple triangles, or just the fact that it's a square, you'd still come up with 196. So let's apply this. Let's use this idea. What is the area of the regular nonagon? Okay, 9 sides. So here's the big idea. Let's start with one triangle. See if we can find that area. Well, that means we got to find this height, which means we need to do a little bit of trick. And we actually did do some of this in some other units. So if I know there's 9 of these central angles, I need to figure out how much one of them is. Well, a full circle would be all of them. So let's divide that by 9. And that's going to equal 40. Okay, so we got one triangle. And here it's 40, but we got to split that in half. So it's going to be 20 and 20. Now we know that each side is 8, so if we split that in half, that's 4 and 4. What that allows me to do is now I can set up a trig relationship using this side, and this angle. And that's going to be a tangent relationship because I have the opposite piece, the adjacent piece. So that gives me tangent. So tangent 20 degrees equals, the opposite is 4 over, we'll call that A because that's going to be our apothem there. Now, by the magic of algebra, we can multiply both sides by A, divide both sides by tangent 20. Let's see what we're going to get. A equals 4 divided by tangent 20. I have a calculator that can do that for me. 4 divided by, whoops, not 2 divided, just one of those. Tangent of 20 degrees. That's 10.99. If we're to round off a little bit there, 10.99. Okay, so the apothem is 10.99. The area of one triangle is going to be half the base times the height. The base is 8, that's easy, times 10.99. Do that, 10.99 times 8 divided by 2. It gives me 43.95. So this is 43.95. But how many of these triangles are there? There's 9 of them. So 9 times 9 gives me 395.6. So this is 395.6. We are going to skip number 2. Why? Because it's towards the end of these notes. And you guys have been doing plenty of work. But let's take a look at number 3. When diving or snorkeling, you should leave a radius of approach or restricted area around certain animals that live in the waters where you are diving. How much greater is the restricted area around a monk seal than the restricted area around a sea turtle? So we're comparing two areas, but we're given two radius measures. Okay, so we got one circle that's 20 with a radius, and we got another circle that's 100 with a radius. So let's compare these two. For the area of this one circle, 20, that's going to be pi times 20 squared. 20 squared is 400, so that's 400 pi. Then for the other radius, it's 100. So what's 100 squared? Well, that's 1 with 4 zeros, 10,000. So the area here is going to be pi times 100 squared, which is 10,000 pi. How much greater is the restricted area? Well, it's 10,000 pi versus 400 pi, so we'd have to do a little subtraction there, and you'd come up with 9,600 pi. Why? Because that's what 10,000 minus 400 is. All right, this next one is very similar, very similar. It involves finding the area of two triangles and then kind of figuring out how much bigger one is. So it's a similar idea, but I'm actually going to let you guys cross it out, just for time's sake. All right, let's look at number 5. It says a regular hexagon has an apothem of 4.6 centimeters. Which is the best estimate for the area of the hexagon? Okay, so that means that the apothem here is 4.6. And it's a hexagon, which means it's going to look kind of, this is very, very sloppy here, but like that. But this piece here is 4.6. So what we would need to figure out is, what is the base? Well, I know that this would be 6 central angles, and 360 divided by 6 is 60. Then we divide that in half again and we get 30. So what I can do is I can say, let's call this B, and tangent of 30 is going to equal B over 4.6 by, SOHCAHTOA relationships and combinations. So I'm going to do 4.6 times tangent 30. Let's see what that gives me. 2.65. Why would I do that? Because it's algebra. I'm trying to get this B by itself. So B equals, what was it, 2.5? 2 point something? 2.6. So that means this is 2.6 and this is 2.6. Let's put those together. We'd get about 5.2. So for one triangle, it's going to be 5.2 times 4.6, then divided by 2. So area of 1 is going to be 1/2 4.6 times 5.2. And if we put that together, let's see what we would get. 1/2, 1 divided by 2, times 4.6 times 5.2. That gives me 11.96, and there are 6 of them, so I'm going to do times 6, and what would they give me? 71 point something. So that looks like it's about C. I did do a little rounding off, so that's probably pretty close there. Alright, we are also going to do number 6 here, because it uses some different words. It uses circumference in it. Okay, remember that the circumference of a circle is 2 pi times the radius. Amusement park ride is made up of a large circular frame that holds 50 riders. The circumference of the frame is about 138 feet. What is the diameter of the ride to the nearest foot? So this 50 riders, that doesn't matter. It's just the 138. Okay, so 138 feet is the circumference of the ride. A large circular frame. Okay, what is the diameter to the nearest foot of this frame? Okay, so if the circumference equals 2 pi r, that means that 138 equals 2 times pi times the radius. Well, if we divide by 2, that would give me 69 equals pi times the radius. So I'm going to divide by pi. Remember, pi is actually a number. So let's take 69 divided by pi. 69 divided by pi is about 3.14. And that would give me about 21.96, or 22 feet. But wait a second, that's not what the question is. That's the radius equals 22. The diameter is double that, 44. Alright, so that's it for the problem solving here. I'm going to skip the rest of it, even if there is any. Let's see. Is there? Yeah, we're going to go ahead and skip those. So we're going to stop here, but we'll see you in the review for mastery for the finale.